Welcome to Excel Magic Trick number 1444. Hey, if you want to download this Excel workbook file so you can follow along, click on the link below the video. Wow, this business analytic problem here is going to be one of the more amazing ones we've seen at the Excel Fun channel. And the different solutions, both logical formulas, array formulas, Power Query, and DAX formulas that we're going to see over the next 4 videos are filled with a bunch of amazing and fun and unusual combination of different tricks. Now, here's the setup. We have a list of customers, and these customers have been sent coupons. Each customer has been sent coupons for each one of these stores. Then when the coupons are redeemed, we have this sales table. So we can see for Sue customer and Miki customer, they have gone to all 3, Public, Trader Joe's, and Wegmans. Wegmans, Public, and Trader Joe's. If we were to look at a Venn diagram, customers who went to Public, Wegmans, Trader Joe's, the customer Sue and Miki would represent this part of the Venn diagram. They went to all 3. If we look at just FAM, FAM went to only Public. So FAM would fall into this part of the diagram. Not only that, but we definitely have some customers like Ben that never redeemed any of the coupons. This is just a visualization of the different possible groupings of customers. But what we need to do is count how many customers went to all 3, how many customers went to just Public and Wegmans, how many went to just Wegmans and Trader Joe. That would be the 3rd group. And then we need to extract the names. Now, this business analytic problem actually was sent in from Bart. He is a lecturer over in the Netherlands. This is the actual original data set that he sent. Now, I'm not going to do the formula version using this data set. You can see boom, 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 and boom. These are the formulas based on this data set. I'm going to use this much smaller data set because it's easier to show and analyze each part of the formulas as we build our formulas. Not only that, but later when we do Power Query and DAX, we'll use this big data set. Now I want to go over to the answer sheet here. And we're first going to have to count each intersecting possibility. Hey, how many times did Mo go to Public? We can see 1. Then we're going to have 8 different groups, 8 different possibilities of coupon redemptions, including the last group where the customer did not go to any of the stores. And we're going to have a different logical test for each one of those based on these counts over here. Then we'll count, and then we will extract the names. That's what we're going to do in this video. Now let's go over to the sheet 1444. All right, here's our customer list, store list, and our transactional data set. Now our first task is for each customer, we need to ask the question, how many times did this customer go to Wegmans, Public, and Trader Joe's? So we'll get counts here from 0 to whatever maximum number there might be. Now, any intersecting cell means we're going to be counting with 2 conditions. For this cell right here, I need to look through this transactional data set. I first need to look through customer and ask the question, is the record customer equal to Gigi? Then I need to go through the store and ask the question, is the store equal to Public? Now, we'll get a 0 there, but of course, Gigi, Wegman, we can see right here. This record counts because the customer is Gigi, the store is Wegman. Anytime we're counting with multiple conditions, the perfect function is the COUNTIFS functions. That means we have to highlight the entire column for criteria range and then put the criteria. Now, COUNTIFS, we're going to have criteria range 1 and then criteria range 2. That means we have 2 logical tests. Those logical tests can be done in any order because all we're interested in is whether we get 2 trues. If we get 2 trues, then we count the record. I'm going to choose to do customer first. So for criteria range 1, I'm going to highlight the customer column. I'm going to hit the F4 key to lock it in all directions, comma. Criteria, well, for this row, I need to look at Sue. Now, this is a relative cell reference. As I copy down, I need the orange one to move to Tyrone, then Abdi, and so on. But when I copy across the columns, I need it locked on Sue. So I'm going to hit the F4 key 1, 2, 3 times to lock the column. Notice as I go across the columns, J is locked, but the 9 is not locked. As I copy it down, it will move from row 9 to 10 and so on. Now that's criteria 1, comma. Criteria 2, now I'm looking through the store column. I highlight the whole column. Hit the F4 key to lock it in all directions, comma. Criteria 2, that's going to be the particular store criteria at the top of this column. Now, look at this cell reference. As I copy down, I need it locked on K8. But when I move across the columns, I need that green cell to move to public and then Trader Joe's. That means I need to hit the F4 key once and twice to lock the row. So as I copy down, it doesn't move to 9, 10, 11. But now as I copy the side, K is free to move from K to L to M. And that's our formula for counting with 2 conditions in this cross-tabulated table. Close parentheses, Control Enter. I'm going to copy it over, and then double-click and copy it all the way down. I'm going to go to the very last diagonally furthest cell away and hit F2 to validate that the cell references are absolutely working, and they are. Now, we can clearly see for customer Sue, we have counts in all 3 stores. For Tyrone, we have counts in the first 2, but not the last one. Now, in order to do our logical formulas over here, we would like to look at true, 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 because there's 3 numbers. True, true, false, because there's 2 numbers and a 0. But guess what? If we use equals the if function, that's a logical function, or the and function, another logical function, not, that's another logical function, or even or. Any of those logical functions and any of the other logical functions understand any non-zero number as true. 0 is the only number it interprets as false. That means, I'm going to click Escape, we do not have to convert these to trues and falses. Now look at this. Here's this column right here. I need to check every single customer and check if it's true, true, true. Well, guess what? The function for checking if we get all true is the AND function. This is a logical function that requires multiple logical tests. Now, the beauty of AND is I can put separate logical tests separated by commas. Now, I could do that here, but AND also can interpret a range. So when I put a range of values, and notice that's a relative cell reference. So as I copy down, the relative range will move to each new row with 3 numbers. It will totally interpret this as true, 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 and when it gets down to the second record, true, true, false. Now, AND will only deliver a true to the cell when it sees true, true, true. Any other combination of trues and falses, it will deliver a false. Control Enter to put the formula in the cell and keep the cell selected, and then drag all the way down. Go to the last cell, F2. The cell reference is looking good. And sure enough, it picked out the only 2 records that have 3 numbers or 3 trues. All the other ones are false. Now we go to our next coupon group. We need to find Weigman's, Public, and did not use Trader Joe's. Now, the one thing I'm going to need to be careful of here is I'm only going to check these 2, and then I need to check if this one is not 0. Because if I put a formula here to check if these are true, well, I get 2 trues here for this record, even though I don't want this one counted. This first customer has already been counted in this coupon group. And we could start here to illustrate this better, because this follows the exact logic. this is a number, meaning true, this is a number, true, and this is equal to 0. So the way I'm going to do that is I'm going to use the AND function again. I'm going to put the first two Wegmans and Publican as a range. So when it sees true, true, and we'll see two trues. Then I type a comma, and the logical test is now going to be, is Trader Joe's equal to 0? And that will work. Notice we have a range with two cells, but it could get true, true. And when this is true also, and we'll see three trues. Close parentheses,
True.
Control Enter, double click and copy it down, and then copy it up one. Now I'm going to come to the last cell and hit F2. Cell references are looking good. And sure enough, if we eyeball this small data set, we see we get a true only for Tyrone. And our formula is working. Here, we got two trues there, but of course we got a false because that's not 0. Now we go to our next coupon group, Wegmans and Trader Joe's. Well, I'm going to use the AND function again, and I'm going to check logical one. That means does Wegman have true or a number, comma. Then I'm going to check whether public is equal to 0, comma. And then for the third logical test, I'm going to check whether Trader Joe's is a number. Close parentheses, Control Enter, double click and send it down. We can clearly see we get a true for Abdi. There it is. Used the coupon. Did not use the coupon. Used the coupon. We also see a true down here. For Teeny, used one coupon at Wegmans, none at Public, and 2 at Trader Joe's. Now, our next logical test, we got to check Public and Trader Joe's equals, and the first logical test is going to be, hey, does Wegmans equal 0, comma, and then logical 2. Since I'm checking the last two, Public and Trader Joe, I simply highlight the two cells. Close parentheses, Control Enter, double click and send it down. Sure enough, we can check 0, 1, 1. I get a true. Mo will be in this coupon group. Now, we're checking just one, and I need to teach you how to construct a none, N-O-N-E, a none logical test using Excel's logical formulas. Now, we could easily say equal to 0, and this is a number, right? And for a small data set like this, the formula might almost be quicker to create. But I want to show you none, which means for the last two customer groups, none of them are true. Because if we had more stores here, this logical construction using the OR and NOT function would be quicker. And I actually have other videos on non-logical construction in my Highline Excel class series at YouTube. Well, I want to look at the OR function first. Now, OR, you could put as many logical tests as you want, or you can put a range. Now, what OR does, anytime it finds one or more true, or said a different way, at least one true, then OR delivers a true. Now, let's just close parentheses. Remember, it's just the last two stores. Control Enter. Double click and send it down. Now, what does false mean when we're using the OR function? It means all of them were false. Now, notice when we see false, that means none of them were true. Well, how do we convert a false to a true using Excel logical functions? We use the NOT function. When I use the NOT function, it will convert a false to true and a true to false. So watch this. I come to the top, F2, and now I put NOT. And that's the construction for none. That means no logical tests were passed. Control Enter. Double click and send it down. Now when we go to the cell with true and hit F2, sure enough, it's reporting true even though everything came out false. All right, you ready? Now we come to the top, F2. That works for both of these, but we still need to check if there's a number here. So now, remember, NOT is just delivering a true or false. So now we use AND. And our first logical test will be whether Wegmans has a count there, comma. And then the logical test, even though we're using two logical tests inside of AND, that thing is looking at two of the stores. Now we come to the end. Close parentheses. Control Enter. Double click and send it down. And that formula, F2, will check for just went to Weigman's. So GG went to just Weigman's. Now we need to do the same thing for public. Equals, and I'm going to start with OR because guess what? I need to check Weigman's and Trader Joe's. So I come over here, Weigman, comma, Trader Joe's. We know that when OR sees both are 0, deliver a false. So now we wrap this in not. That's our checking if none of them are true. We could check this, Control Enter, double click and send it down. I think there's one customer. There's two of them. F2, sure enough. I think there is only one because down here, this 0 and 0, when we check to see if public has a number here, well, FAM will come out true, but bin will come out false. So now we come up to the top, F2, and now we do and. We're checking if public, boom, is that a number, comma. There we go. Second logical test is our none. Close parentheses, Control Enter, double click and send it down. Sure enough, the only true is for FAM. Now we need to check none and is a number equals and, not, or. And we're checking the first two to see if none of those came out true. Close parentheses, close parentheses. So the not, that's in the first logical test, comma, and then we're simply checking Trader Joe's. Is it a number? Close parentheses, Control Enter, double click and send it down. When we come down to the only true, when we look over here, Cranny only went to Trader Joe's. Now our last group is none equals not, or, and we simply highlight all three cells. Close parentheses, close parentheses. We can clearly see this is going to be faster than checking equal to 0, equal to 0, equal to 0. Even if it was about the same number of characters, it's much faster to just highlight the range. Control Enter, double click and send it down. And sure enough, we should have two trues. Ben and Sheila Dawn did not use any of the coupons. Now we can come up here and simply count trues equals COUNTIFS, the criteria range as a relative cell reference, comma, true, close parentheses, Control Enter, and copy it to the side. That will give us our count for each coupon group. If we go back over to our data sheet, we could see we did the same COUNTIFs here, but with a much larger data set, the same logical construction, and the same COUNTIFs. Now let's come back over here. Now, if we want to extract customer names from over here, and this is a lookup situation, but guess what we're looking up? We're going to look up trues. Anytime I see trues, then go over and pick out the name. Anytime you have a lookup value, in our case true, and you're trying to look up multiple items, which mean we have a column and we have a lookup item, and there's more than one match, you can't use standard lookup functions. We have to switch over to array formulas. Now, the first problem when you're looking up and you have multiple matches is, guess what? I have some relative positions. I'm either going to look up the first, second, third, fourth, and so on items in the list. If I get two trues, the formula down here has to know the actual position. That would be for Sue's name in this list, it's relative position 1. If I'm also going to look up Mickey, that name is in the 10th position. So somehow in our formula, we have to deliver first the relative position 1 for this row right here. And then as I copy the formula down, this next cell needs to see relative position 10. And that's the hard part of the formula, because we can just use index. Index can see 1 and pick that out. Index can see 10 and pick that out. So let's just see if we can, as we copy our formula element down, pick out the relative positions. All right, the first thing you do anytime you are doing an array formula with relative positions is you have to generate all the relative positions in your formula. Now I'm going to use the row function, and I'm going to highlight all of the names. And notice they're sitting in row 9 to 20. If I just for a second, close parentheses, and F9. That's giving me 9 to 20. That's not what index function needs. It needs 1 to whatever the last one, I think 11. Control Z. So I'm going to subtract from row minus row tab just the first cell. Now, I actually forgot to lock the cell references. I'm going to hit F4 here, close parentheses. Then I'm going to click inside row, click on reference to highlight everything, and then hit the F4 key to lock it. By the way, when I just did this little bit right here, F9, to show you this array of numbers, that's actually an array operation. The row function is delivering multiple items, Control Z. So there I'm using row to deliver an array of items. Here, row is just going to deliver the actual cell 9, or the row 9. So if I hit F9, 9. Now, if I click at the end and F9, 0 to 11, not quite what I want, Control Z. So I come to the end and add 1 back in. Now I'm going to click at the end, F9. That is a famous, well-known way to generate all the relative positions in an array formula. There are other ways to do this, but this is by far, Control Z, the most robust way. If I were to insert rows up here and all that kind of stuff, it would still always deliver the right relative positions. Now notice that gave me all of them. And for this first cell, I want 1. And then as I copy down, I want 10. Well, we first have to take that array there and divide it by a logical test. Well, this is the column that tells us the trues and falses. And notice it's exactly parallel to this size here. So we simply hit F4 and then ask the question, are any of you equal to true? Close parentheses. Now, in the denominator, if I highlight this and hit the F9 key to evaluate this array operation, I get an array of trues and falses. First and 10th position get a true. The rest are false. Now, notice since this is in the denominator, taking the relative position 1 divided by true will give us 1. All of the relative positions that are divided by false will give us a divide by 0 error. Control Z. Now, if I click at the end and hit F9, there's our array of relative positions for this column, including the divide by zeros, which serve as a filter, filtering out the relative positions we don't want. Now, we just need a way to pick out the first one, then the second one, 10, as we copy the formula down. Control Z. Well, we'd like to use the small function. Small 1 would pick out 1. Small 2 would pick out the 10. But instead of using small, we're going to use the amazing aggregate function. Now watch this. When I hit Tab, aggregate stole that parentheses that we were using in our formula. So I have to be sure and open parentheses. Well, the first argument is function number. If I scroll down, there's 15. So small function would require that we use a special keystroke for the array formula. But aggregate knows how to handle array operations without any special keystroke. So that's why we're using aggregate to act like small by putting 15 in the function argument, comma. This argument options is amazing because now we can choose 6 to ignore the divide by 0 errors. So I type a 6, comma. And this is the magic of aggregate when we're using small. That array, that is an argument that's inside of aggregate. And it will handle array operations without any special keystroke. That whole thing has got a bunch of array operations. So we're going to use aggregate. Now we come to the end, comma. Okay, that's 1, 2, 3 as we copy down. So I'm going to use the rows with an S function. Now we're sitting in cell O25. So I'm going to type O $25 colon O25 close parentheses. Now rows with an S is different than row because all it would do is read the range and tell you how many rows. 25 to 25 is 1. But notice there's no dollar sign for that 25. So when we copy down to the next row, it'll be 26. Rows, we'll look at 25 to 26 and report a 2. So that will be our number incrementer as we copy down. Now I'm actually going to click on the K argument and copy this with Control C because I'm going to use that later in the formula. Close parentheses on aggregate. Now let's enter this. Control Enter. copy it down. And if I copy it to the side, notice it's doing exactly what we don't want. You know what? I'm going to come here and hit F2. Look at that right there. That is supposed to be a relative range. So as I copy to the side, it moves. But when I copy down, it's locked. So I'm very careful, and you have to highlight everything there. That range, I need to hit F4 one time. The rows are locked. So as I copy down, it remains locked there. But column O is not locked. When I copy across the columns, it will move to P. Control Enter. Double click and send it down, and then copy it to the side. Now there we go. 1 and a 10. So for this coupon group, we're going to get Sue and Miki. For this column, we only have one, and it's the second person Tyrone. Since those are the relative positions, we can use that inside of index. F2, I simply type index. Now, index array, those are the items we want to look up and return to the cell. So I highlight all of the names. I need to hit the F4 key to lock it, comma. And that whole aggregate is just going to deliver the relative position, or for index, they call it row number. Now I come to the end, close parentheses, Control Enter, double click and send it down. I don't know why it's not going to the last one. Drag it and drag it over. Those names are working perfect. Now we just need to get rid of the num errors. I'm going to hit F2, and what we don't want to do is use the if error function. Now this is an array formula, and array formulas take a lot of time to calculate, especially on large data sets. If we used if error, that means in order to determine if there was an error, it has to run the array formula in every single cell. And for array formulas, you don't want to do that. We're going to use the if function. We can use the if function because there is an alternative logical test that we can use to turn off the formula when it starts to see num errors. Or, more specifically, when it gets past row 2. Notice up here, we know how many should be in this column. We know how many should be in this column. So I'm going to Control V. I copied that rows. That's a number incrementer that gives us 1, 2, 3, 4, 5 as I copy down. And I'm going to ask the question, are you greater than this count up here? Now I need to hit F4 once and twice to lock the row. So as I copy down, it's locked. But when I copy to the side, it moves to the next count. That's our alternative logical test, comma. If that comes out true, which means I'm past row 2, what do I want? I'm going to show nothing right here in value if true, double quote, double quote. Now, that is a zero-length text string that will actually be text in the cell, but it's what we use in formulas to show nothing. Now, comma, value if false, I run the array formula. Notice it'll only run the big array formula in the first 2 cells. The rest of the time, that part of the formula will not run. Close parentheses, Control Enter to put this formula in the cell and keep the cell selected. Double click and send it down. Copy it all the way to the side. You've got to be kidding me. Look at that. For each group, we have extracted the correct customer names. Now let's go look at this data sheet, and we're going to scroll over, and we'll pick like this formula right here. This is for no coupons were used. If I hit F2, now this formula has to go over a lot of rows from 13 to 1012. And then every single formula here has to run and calculate over those large ranges. So that's why when we get to this cell right here, F2, it's just running the logical test. It comes out true, so it dumps double quote, never gets to the index array formula. Now if we go back over to 1444, that was a lot of fun with customer analysis of coupon redemptions across our 8 categories. We saw an array formula to extract all of the customers in a particular group. We saw a bunch of logical formulas, including the none construction. We saw how to count how many customers using COUNTIF based on those columns. And we started off with COUNTIFS to count with two conditions. Now, this was a formula video where we had a lot of intermediate steps. In our next video, we're going to see how to make this calculation without any of these cells, including the fact that it will be a single cell formula. And as we copy to the side, it will change its logical test. So next video, we'll see an array formula. And then the videos after that, we'll see Power Query and DAX. Now, if you like the video, comment, click thumbs up, and sub. And we'll see you next video.